Hello everyone. In today's video, let us see one question that is based on some extraordinary approach. The concept that I'm going to use in this video for solving that question is already known to you, but let us see how to figure out the best approach when we face some unique question, some question based on new concepts in our JEE Advanced exams. Okay, so see the question. Question says that consider the locus of a moving point p x comma y in the plane which satisfies the law 2x square is equal to r square plus r raised to the power 4, where r square is equal to x square plus y square. So basically we have to first consider in our mind the locus of a moving point px comma y in the plane which satisfy this relation, and which one of the following is correct. We also have to find it. One of the following must be correct, and there must be 4 options. In this question you can see that the first option that is still being written on your screen is, the option is, for every positive real number d, there exists or there is a point x comma y on the locus such that r is equal to d, right? So which means r square is equal to d square. Okay. Second is, for every value d such that d lying between 0 and 1, there are exactly 4 points on the locus such that r is equal to d. So these are the first 2 options. Third option is the point always lie in the first quadrant, and option number 4 is the locus of point P is an ellipse. So out of these 4 options only one is correct. We have to figure out the correct option. Okay, as you can see that the questions, by now this question should be clear to you that this question belongs to, somehow it belongs to coordinate geometry, right? But it is not as simple as we face the question usually in our books or in our study materials, or those questions which we generally solve in our class. Since it is already said that r square is equal to x square plus y square, so from here you might get a hint that it might be some sort of circle. The point x comma y, maybe it lie on some circle, but that is true only if r is fixed. Here equation is itself in terms of r, so maybe the r itself is a variable, right? Okay, so the correct approach of solving this question is still not clear. Let us see what else we can do. Let us just get started. Let us just put the expression of r square in the given equation, and let us see what equation we are getting after replacing r square by x square plus y square, and then we will try to draw the graph of the resulting equation. So let us just do some manual work here. It is general approach that I'm discussing now. That is 2x square equal to r square plus r raised to the power 4, where r square is equal to x square plus y square. So now 2x square is equal to x square plus y square. Oh, there is a mistake, it should not be whole square. Okay, it should be only x square plus y square. Okay, and now x square plus y square whole square. So from here what we are getting is x square minus y square is equal to x square plus y square whole square. Okay, now if we try to draw the graph of this equation, it's indeed very tough. It is indeed very difficult to draw the graph of this equation, and you can get some general idea about this, that since RHS is a positive, so LHS must be positive. So the graph is lying between those, in those region in which x square is greater than equal to y square. So that is difficult. So let us see another method. That's it, the best method. Since r square is equal to x square plus y square, and you must be knowing this from the polar coordinate, that x is equal to r cos theta. We can assume x is equal to r cos theta, where theta is polar angle of the point x comma y and r is the polar distance of the point x comma y from the origin, right? You might recall this thing. This O is called pole, and this point P, the Cartesian coordinate is x comma y, and the polar coordinate should be r theta correspondingly. Okay, so if I substitute x is equal to r cos theta in this equation, we are getting that 2r square cos square theta is equal to r square plus r raised to the power 4. Now since r cannot be 0, so, or if r is 0, then we are getting only 1 point. So removing r square from both sides, we are getting 2 cos square theta minus 1 equal to r square. So from here we got r square is equal to 2 cos square theta minus 1, which is cos of 2 theta. Now you can see, since cos r square is always greater than equal to 0 for all r belongs to real number, therefore cos 2 theta greater than equal to 0. So we know that cosine is positive in either fourth quadrant or first quadrant. So 2 theta lies between minus pi by 2 to pi by 2, which means theta lies between minus pi by 4 to pi by 4. Okay, so we can see from here theta lies between minus pi by 4 to pi by 4. Also, as theta increases, we can see we also know that as theta increases, cos of 2 theta must decreases, because we know that between 0 and pi, cosine graph of cosine is decreasing. So r square also decreases, therefore r square equal to cos 2 theta. When theta is equal to 0, r square is equal to 1, so r is equal to 1. Okay, when theta is equal to plus minus pi by 4, r square is equal to cos of plus minus pi by 2, which means r square equal to 0, so r is equal to 0. So depending on the value of theta, as theta is increasing from theta equal to 0 to theta equal to pi by 4, r is decreasing from 1 to 0. So it should be clear to you. So as theta increases, r decreases. And what is r? R is the distance of the point x comma y from origin. So as theta increases, distance of point from origin decreases, which means point becomes closer and closer and closer to origin as theta increases from 0 degree to 45 degree, or you can say in fourth quadrant from 0 to minus 45 degrees. So this should be the possible trend of the graph. And again in the fourth quadrant, I'm just drawing the approximate graph. Obviously it is not the exact, it should be the mirror image of each other. The first and the fourth quadrant graph should be mirror image of each other with respect to x-axis. So this is actually theta, this is r, and this is the point P x comma y, you can imagine from here. And as theta equal to 0, the r is equal to 1, which corresponds to 1 comma 0 point. And as theta increases, r decreases. As you can see, at an angle 45 degree, r diminishes to 0. Okay, so polar distance becomes 0. Similarly, at theta minus 45 degree, again r diminishes to 0, right? So this is actually for your understanding, I just show you how I drew this portion of the graph. And as you can see, cos 2 theta can also be written as 2 pi minus 2 theta, and if you take 2 common, so 2 times pi minus theta. In fact, plus you can also take as plus 2 pi plus theta, also plus minus in both cases. So as you can see that if r equal to cos 2 theta is satisfied by theta, then r square equal to cos theta is also satisfied by pi plus minus theta, right? So which means that there must be one more branch corresponding to every theta. There is another angle pi plus theta, which also satisfy, right? So there should be, I think the graph of this equation is symmetric about origin, as you can see here. At an angle theta, if you see a point, there is should be one more point at an angle pi plus theta, and similarly at an angle pi minus theta also. So the graph is symmetric with respect to origin, as you can see from here. So this is actually the complete picture of the graph, and the graph is a symmetric curve. And obviously you can see from here how I have applied uh, the general concept that we study in our class. Okay, so let's say r square is equal to d square, where x square plus y square equal to d square, which means this is equation of a circle with varying radius. D should be obviously r square is equal to cos 2 theta, so d square is equal to cos 2 theta, so d must lie between 0 and 1, right? So radius of the circle can be between 0 and 1, and as you can see here, so if I draw this circle, I can see that this circle is intersecting our graph at 4 points. You can see these 4 points. So corresponding to every r, d belongs to 0 and 1, r equal to d has 4 points in the locus. R equal to d has 4 points in the locus. And curve is obviously not ellipse. Actually this curve is called lemniscat, which is also the symbol of infinity. So yes, so last option, that is saying that the locus is ellipse, is false. So let us figure out the correct options. For every positive, no, not for every positive. In fact, for d between 0 and 1, so second answer is correct. Second answer is correct. For d between 0 and 1, r is equal to d has 4 points, so this is correct. Third is point always lie in the first quadrant. No, you can see the graph is lying in all 4 quadrants, so this is wrong. And last is ellipse, so this is also wrong. So the correct answer is option B is correct. I hope that you must have understood the solution and also the approach. See you in the next video. Okay everyone, keep solving. Take care.